Hi, my name is Pranjali Beri, and I work in the Li Wei Lin lab in the Mechanical Engineering Department at UC Berkeley. And my research is on microfluidic devices. So a microfluidic device is just a way to move around small volumes of fluid. Now, an example of a microfluidic device is something like this. It's a little difficult to see, but basically what's on here is a tiny little channel and a little component inside of it, which I will explain later. So you can control the movement of fluid through these channels through the use of valves. Currently, the types of valves that are being used are externally regulated pressure valves called pneumatic valves. The way these work is they're hooked up to a pressure machine outside of this tiny device. You just stick a little tubing in there and it's connected to the pressure pump. And the way the pressure pump changes its pressure, and that either opens or closes the pressure valve inside, which allows the fluid to either enter or be blocked in the channel. So this regulation of fluid is very desirable because it can create a lot of potential devices that can be used for any number of purposes. But we don't want to have this bulky equipment to carry around because it makes it less ideal for on-the-spot like diagnostics. So the research that I'm working on is creating passive components. By passive, I mean they're not externally regulated. They're not hooked up to anything. They move around on their own. They control flow on their own. So the one I showed you earlier, this little grayish spot in the middle, if you can tell, is a diode. And the way a diode works is that it allows, just like in electricity, it allows the flow in microfluidics to enter in the forward direction into the channel. But if you want backflow, or in the reverse direction, it blocks the flow. Now, it's a lot easier to see how it does this when you look at the larger image of the diode. This is the diode. When the flow comes in through here, that way, it will open around this pivot point and let the flow through. But if the flow goes in the reverse direction, it will close on its own and block the channel, which will stop the flow in the opposite direction. This is ideal because it eliminates the bulky equipment and also requires less time to actually fabricate.